Hi friends, welcome to follow up. Let's have a look at problem 1351. Count negative numbers in a sorted matrix. So notice that the matrix here is sorted. So we are going to use some special order of traversal so that we can save some time. So let's first look at the problem statement. So here we are given an m by n matrix called grid, which is sorted in non-decreasing order, both row-wise and column-wise. So this is the main assumption for this problem. Then we are required to return the number of negative numbers in grid. So here are two examples. The second example, the output is 0, so you can quickly examine that there is no negative numbers. And in example 1, so the output is 8. Actually, you can draw a picture and look at the distribution of the negative numbers in the sorted matrix, both row-wise and column-wise. So here the constraints are the following. First, m and n are the number of rows and number of columns respectively. Both of them are bounded above by 100. So the element can be negative, can be positive, and can be 0. But overall, it's bounded in absolute value by 100. So here, the follow-up is that could we find an O n plus m solution for this problem? So here, I guess that this is an easy problem as marked by leetcode. So due to the problem size, so we can do a double for loop and then do a test to check if the number is less than 0, then we can increment the count. That's one way. However, that way, the time complexity will be m by n. Up to a constant, right? So here actually we can do the examination so with a specific order. So we can start from top right towards bottom left, or the reverse direction. In other words, from bottom left to top right. So it would be intuitive if you draw a picture and look at the distribution of the negative numbers. For now, we are going to look at the code, and in between, we are going to explain the logic. The main thing to notice is that both the row and the column are in sorted order, right? So first, I'm going to write like this. So let me use rows and columns. That is length of grid and length of grid 0, right? So we get the number of rows and number of columns. So actually, it's also you can use m and n like in the constraint, but that's just the naming. So then let's do the count. So originally we just have 0. We initialize it as 0. So we are going to return the final state of this variable count, right? So basically we can start from a position, so row, column. So I'm going to start from the first row and the last column. Right? Columns minus 1. So here the main thing is to use the assumption that is the grid is sorted non-increasing in both row and columns, right? So now basically we are going to do this while column index is greater than 0, greater than or equal to 0, and row less than rows. In other words, it's inbound. So we are going to decrement the column variable, and we are going to increase the row variable due to the assumption in this problem. So first we are going to check if grid row column is less than 0. So if this is less than 0, then the whole column or below this the row index will be negative, right? So we are going to do the count increment by this number, the rows minus the row, right? So actually this is counting from the row index up to rows minus 1, right? So start from here and then ending at this index. Then you use the second one minus the first one and then plus 1. That's it means that in the current column and below the row index, all the numbers are negative. The reason is that the matrix is sorted in a non-decreasing order, a non-increasing order in column. So this one, and then once we finish examining this column, so we can decrement by 1. So go to the left. So otherwise, so if this is greater than or equal to 0, right? So we are going to increment the row so that we can meet negative numbers. So that's the whole logic. So now we are ready to return the number of negative numbers. So this is the one solution. So here, what we are going to do, so here the direction is that we start from 0, so n minus 1, right? So the row index. In other words, we start from top right, then we move towards bottom left. So that's the one way. So before we make any comments, let's first do a check. Yeah, it passes one example. Now let's look at the generic case. Yeah, it passes all the generic cases. So actually, in a symmetric fashion, we can do another direction. Let's see. Let me copy this part. I'm going to change this one to be version v1. So now what I'm going to do, I'm going to start from here, m minus 1 and 0. So in other words, bottom left, right? And then I'm going to towards top right. So we have rows and we have columns. The counting is 0. So originally we are going to have we're going to add rows minus 1, right? And we're going to we are at 0th column. Then we are going to decrement the rows and increment the columns. So we are going to judge this by if rows, because we are going to decrement, we want to make sure it's still inbound, and also let's see, if row is greater than or equal to 0, and we want to increment the column, so we want to make sure it's inbound, it's less than the column number of columns. Then we're going to do this check, right? So if the current value is less than 0, so the count will be incremented by, I'm going to change this to be columns minus the current column index, because in the current row, right, from this index to cos, so minus 1. So this start index and the ending index, both inclusive. These numbers are negative, right? Because the rows are sorted in non-increasing order. So this way, I'm going to, once we finish examining this row, so we're going to decrement the row by 1. And otherwise, so we're going to increment the column by 1, right? And then we're going to return the count. So this is the second solution. Actually, the idea is the same. So now let's do a test. Yeah, it passes one special example. Now let's look at the generic case. Yeah, it passes all the generic cases. So overall, you can easily examine that these two formats of solution has term complexity m plus n up to a constant. So with that said, basically that's about it for this problem. So I would say that this problem is easy, but it deserves some thought. It's an interesting one. That's it for this video. Thank you.